For years, my favorite 3D scanner was the Einstar from Shining 3D. It was released in 2022, and it set the bar for consumer-grade 3D scanners by being reliable, accurate, and affordable. Now they released two upgraded 3D scanners to the Einstar lineup. The Einstar 2, which is the successor to the original Einstar, and also the Einstar Rockit, which provides even more performance. In this video, I'm going to quickly go over the features of each scanner, test out some of the scanning modes, and show you the results. I'll have future project-related videos doing an EV swap on my 1983 Honda Civic wagon, so we can really test out the capabilities of each scanner. If this sounds interesting to you, make sure you're subscribed and hit the bell icon so you don't miss it. Both scanners were provided to me by 3D Wonders to test them out. They're a one-stop shop for all your 3D scanning needs, from beginner to metrology-grade scanners, tracking markers, scanning spray, and even reverse engineering software. So if you're in the market for a 3D scanner, go to 3dwonders.com. And checking out our sponsors really helps out the channel and allows me to make more videos like this. Similar to the original Einstar, both scanners come in a rigid fabric case, and it neatly stores the scanner, tracking dots, calibration board, and even two batteries and a charger, because both scanners now have the option to be used wired with a provided USB-C cable or wireless using Wi-Fi. The calibration routine is the same for both scanners, which only takes a few minutes to follow the step-by-step instructions. Both scanners now use a new software interface called Einstar Hub, and it has some upgraded functionality, but overall has the same feel as the legacy Einstar software, so it's pretty intuitive. Within the software, you can easily delete unwanted scan data and clean up the point cloud. After you capture all your data, the auto alignment feature works flawlessly almost every time. The software meshes the point cloud, and then you can export it to a format like an STL, where you can load it into your preferred design program. To test out the scanning performance, I'm going to scan this little turbo, the engine bay on my wagon, and a 123 block. These objects represent most of the nuances you'll encounter using a 3D scanner in the garage, from a small part to a large area, shiny surfaces, dark parts, so it'll give us a good feel of the capabilities of both scanners. First up, we'll scan this turbo in infrared mode. In IR mode, we don't need to use tracking markers because the scanner basically shoots a blanket of infrared dots onto the object and records how those dots spread around it. Then, while you move the scanner around, it matches what you already scanned to the new scan. And this mode has a larger field of view, so the scanning process is really quick. Both scanners performed amazing. I'd say the Rockit was able to capture a little more detail than the Einstar 2, but both are pretty great. Next up, I'll scan the turbo in laser mode. While the Einstar 2 has 17 parallel lines in laser mode, the Rockit has two options: 38 cross laser lines and 7 parallel lines. For this scan, I'm going to go with 38 cross lines. Unlike IR mode, we need to use tracking markers, so the turbo will be on this turntable with markers randomly scattered. Laser mode captures more details compared to IR mode, but the trade-off is a narrower field of view, so the scanning process is a little slower. You can definitely see more details on these scans where the threads are more pronounced, and there's more texture picked up on the casting. Next, I'll scan the engine bay in IR mode. Since this is a large area, I'm going to set the resolution to 2 millimeters. You typically don't need sub-millimeter resolution on large areas like this because it'll be so much information and it doesn't add a lot of value. Plus, it'll take a lot of computing power to process and it'll just bog down your workflow. So I found that 2 millimeters gives you enough information and it doesn't hog your processing power while you're designing. It's impressive how quick IR scanning mode is for these scanners, and I hardly ever lose tracking. You can see both scanners are able to pick up the shiny bits, dark bits, and all the other components that you need to do a clearance analysis for large parts. One feature that sets the Rockit apart from the Einstar 2, and probably why it's slightly more expensive, is markerless laser scanning. Typically, I wouldn't scan this large of an area in laser mode because adding tracking markers is such a pain in the butt. And you always need twice as many as you think. So markerless scanning is such a game changer when you need precise scans to make adapter plates, pick up splines on a transmission shaft, or other reverse engineering projects. Finally, I'm going to scan the 1, 2, 3 block in parallel line mode. This mode is supposed to be ideal to get accurate deep hole scanning and finer features. The field of view is the smallest out of all the modes, so I did lose tracking a bit more frequently, but the software was able to pick it back up pretty quickly. This time I sprayed the block with scanning spray so we can get the best results. And the scanners were able to get most of the threaded details, and you could easily use the mesh data to measure the thread pitch and depth. I'd say the Einstar 2 was able to get a little more detail than the Rockit on this one, mainly because it has 17 lines as opposed to 7. Although this isn't the most accurate accuracy test, I measured the 1, 2, 3 block with digital calipers to compare the measurements from the 3D scans. I'm using Autodesk Fusion and using the measure tool to simply pick from one point to another on all 3 dimensions. And here are the results, and I'd say the scanners are pretty accurate. The largest difference is 0.1 millimeters, which is about 1.5 millimeters over a meter, or just under a 16th of an inch over 3 feet. It's definitely not metrology grade accuracy, but more than enough for a garage or a small shop. When the Einstar first came out, it set the standard for consumer-grade 3D scanners, and it's great to see the Einstar 2 is a legitimate upgrade instead of just a spec bump. Also, with the Rockit, it's closing the gap between consumer-grade and professional, and giving us the perfect blend between cost and performance. I'm excited to put both of these to the test as I get into the EV conversion. Up next, I'm going to pull out all of the bits on this Nissan Leaf that I need for the conversion, and 3D scan everything so I could use it to design what I need to fit into the wagon. I'll leave links in the description to where you could get more information about these scanners. And if you want to learn more about 3D scanning or are interested in modifying cars, consider subscribing and hitting the thumbs up button so the algorithm knows to push this video out to more people. Let me know in the comments if you want me to test these scanners against any others, and as always, thanks for watching.